Welcome back to my channel, Statistics for Applied Linguistics. I'm Dr. Marnie Menegra, and in this video, we are looking at, again with inferential statistics, the chi-square goodness of fit. Now, what are inferential statistics? Well, there are two types. So the first is descriptive statistics, and this describes summaries of data using percentages, ratios, or raw numbers. So in the case that you're saying 75% of the participants strongly agree, or 22 of the 25 participants strongly agree, these are descriptive statistics. The challenge with descriptive statistics is these numbers are only true for the participants in your study, and you cannot assume that the population that your sample represents would respond in a similar way. Inferential statistics, on the other hand, allows you to make predictions or inferences about the population based on the sample. So if we have a Likert scale and we use inferential statistics to analyze it, and then in this case, we can make an inference that whatever the sample is responding would be true for the population that the sample represents. So again, this is the chi-square test, and I'm showing you the formula here along with a link to another YouTube account where you can go and learn how to do this by hand. We do not have to do this by hand. We are going to do this in JASP, and I will show you how to do this in JASP towards the end of this video. But the chi-square, again, is a hypothesis test used to determine whether there is a significant difference between the expected frequencies and the observed frequencies within certain categories. And there are two types. So the first, which we are looking at in this video, is used to count frequency. This is the chi-square goodness of fit. And it is used to count frequency and will be used to determine whether a population or set of responses fits an unknown distribution. This is used for a qualitative survey to see if the responses are significant or if they are based by chance. And a qualitative survey, again, we're going to look at a Likert scale. You can also use this with a yes, maybe, or no responses. It's not going to be as reliable as a Likert scale would be. But then also you can use this if we're counting frequency. In the case of, as an example, with child language. So if we look at the Burko-Gleason WUG test, and we're looking at the frequency that 2-year-olds and 4-year-olds can add inflectional affixes to a noun, we can then see if that would be true for the majority of children at that age. Now, the chi-square test for independence, we looked at this in a different video, and this test is used to see if there's a relationship between two variables or to see if they're independent or dependent. This test can be used as a non-parametric test if the sample size is small and the distribution is not normal. So in the case that you have less than 30 participants and you do the Shapiro-Wilk test and your sample size, the distribution of the sample is not normal, you cannot use a t-test or an ANOVA. You would use the chi-square test for independence. To learn more about that, please go watch the video on this chi-square test of independence. So in this video, we're looking at the chi-square goodness of fit. And so this is an example of a Likert scale where we're rating the following statements on how well you agree, with 1 being low and 7 being high. In this particular case, when you're writing a Likert, you would want to paraphrase the statements and add them 2 or 3, or ask the questions 2 or 3 times to make sure that the participants fully understood the question. You don't want to ask the question only once. So, and then you're going to add together the numbers for each of those statements. But let's look at how we would analyze this. First, once you have the data in Excel, you're going to open JASP, go to computer, and figure out where the data is. Notice here how the data is labeled. Now, for the Likert, we have strongly agree, agree, neutral, disagree, and strongly agree. For each of these statements, so this one would be cultural interdependence, language behavior, and cultural identity. So we've got everything added up with the strongly agree, agree, neutral, disagree, and strongly disagree. So it's coded. The Likert data would be nominal, and then the information for each of the questions would be scale. So the data needs to be labeled correctly. Then once you have everything in JASP, you're going to go over to frequencies and click on multinomial test. So this is in a different place than the chi-square for independence. And then we're going to take the Likert over to the factor. And then each of these categories or each of the questions into the counts. And then you would go down to test values. Now, here we have equal proportions. So we don't need to put in the equal proportions here. In this case, I'm showing you what the equal proportions would look like under expected proportions, but you don't need to do that because we're using a multinomial test and we are believing that they're equal. What this means is that each of the participants has an equal chance of clicking any of these responses. So these responses are all equal. They can select them however they see fit. Now, if we were comparing, if we did a replica of the Burko-Gleason WUG test and we knew what her results were, we then could go into expected proportions and put in her results and then test our preschoolers to see if we get the same results. So then we're comparing the expected, which we know, to what we've actually discovered through our test. In this case here, you're just going to go to equal proportions. And then we're going to click on descriptives and descriptive plots. So, and you want to make sure you've got a confidence interval at 95%, and you can click on the descriptive plots. It will give you the results of the multinomial test. And then the chi-square number again tells us how much of a difference exists between the observed number and the expected number. The expected number is going to be equally distributed. The degrees of freedom is the number of factors minus 1, and the p-value is the probability that the observed measure is greater or equal to the expected results. Now, I'm going to show you what this will look like, but first you can see here with the descriptive plot, this is going to be the output that you will get in JASP. Let's have a look at this going live. So first, here are my references. I'm going to stop sharing here and I'm going to open up JASP. And now we're looking at JASP. We're going to open up the menu, go to the computer, and I have this on the desktop. I'm going to show you two different sets. So first we'll look at the Likert data, just general Likert data. I want to show you what happens if you do not put letters or numbers in front of the strongly agree to disagree. So here we have, this is nominal, this is in scale, and these are different questions or sections. Now I'm going to go up to frequency, and I'm not going to go to contingency table. I'm going to go to multinomial test for the goodness of fit, take this over into factor, put this into count, and then I can leave it because we want equal proportions. And then we want to click on descriptives with 95% and put on the descriptive plots. So here we have the tables are organized very nice. But what we can see in this table here is, if you notice, it's going to sort everything automatically in alphabetical order. So the way that we can prevent this, and notice how here we've got a p-value of 0.001, so this is significant, but the data doesn't look right. So let's try this again. We're going to open up another file, and I'll show you the revised Likert data. I'm going to have to stop sharing this screen again and go to the new one as soon as it opens. And we'll go to the revised data set here. So notice how in front of each of these uh, types of responses in the Likert answers, I've put a letter in front of them, A, B, C, D, E. So when I go to the multinomial test, put the Likert answers in, put the counts in here. It's going to give me the exact same information. Again, we want the descriptives with a 95% confidence interval and the plots. Make this a little larger. You can see now that everything is sorted properly because it's in alphabetical order, and I've just put a letter in front. So now this looks much better. You can take a screenshot of this and put this directly into your thesis. For each of these sections or questions, you're going to want to do them separately. So you can't do them all at once with a chi-square. You have to go through each section or set of questions separately. But as you can see, once you've got letters in front of the list here, strongly agree to strongly disagree, it's going to sort it properly. Otherwise, it would be in alphabetical order and it's not going to give you the proper visual that you would want. Okay, this takes us to the end of this video for the chi-square goodness of fit. And thank you so much for joining. I look forward to seeing you in the next video.